Hello everyone, welcome back. In this session, we will learn how to solve the practice problem implement queue using linked list. So first, let us understand what is queue. Basically, queue is kind of a pipe in which we enter elements from this side and we remove elements from this side. Entering elements means pushing elements and removing elements means popping elements. Basically, a queue follows the concept of first in, first out. That means FIFO. Now remember one more thing, that this side is known as the rear side and this side is known as the front side. I hope the basic concept of queue is cleared. Basically, we need to complete the push and pop functions to implement queue using linked list. So let's start. Okay, what you need to do is you need to go to the practice portal. In practice portal, in the difficulty section, choose basic. Then you need to find the problem, implement queue using linked list. Once you find the problem, you need to click on solve. Okay, now let's solve the problem. Give me 1 minute. Okay, here is the question. Let's read it. Implement a queue using linked list. A queue is of two types. 1x, a query of this type means pushing x into the queue. 2, a query of this type means to pop an element from the queue and print the popped element. I hope the question is clear to you. We would be coding it over here. We would be coding it here, over here and here. Okay, so let's start. Let's code the question. Okay, so first thing, an important thing is I need to declare a class node. So let me remove the comments from here. Okay, and this. Okay, this was the first step. I needed class node. Okay, then I need to go over here, press enter. I need to declare a function def init. Okay, then circular bracket self. Okay, then colon enter. Over here I need to write self dot head. Okay, over here it would be equal to none. Initially its value is none. Enter. Self dot tail, end of the queue, equal to none, because initially this is also none. Now let's start by the push function, right? So new underscore node, okay, equal to node item. Okay, node circular bracket item. Okay, enter. Over here next thing is if self dot head is none, okay, and or basically or self dot tail is also none, that means there is nothing, it's empty in the start, is also equal to none. Then what do I need to do? Then I need to add the self dot head equal to new node. Basically initially if there is no element, so that means the head and tail would be the same element, right? So new underscore node. Okay, 1 minute, enter. Self dot tail is also new underscore node, right? Okay, now this is for initially when there is no element, but if there are elements already present, then what? Then backspace, 1 minute, else, okay, colon enter, self dot tail dot next. Okay, because more elements are keep on adding, right? So in the tail more elements would keep on being added. Node enter, and self dot tail equal to self dot tail dot next, right? Enter. Now this was the push function. Now I need to do for the pop function. Now remember, in the pop function there can be a condition when the queue is empty, right? If the queue is empty, that means you cannot pop any other element. So basically there could be a condition in queue when the queue is empty, right? That means that there is no other element present in the queue is empty. In this kind of solution you cannot pop an element because the queue is already empty. So in that kind of situation you need to check, because if the queue is empty then you need to return with -1. Okay, so let's do that. Let's start with the pop function over here. Okay, enter. First if self dot head, okay, there is no head, equal to none, then what? Then what do I need to do? Then I need to return with what? Return with -1, like I just told you, right? 1 minute, I added a slash over here. Now let me go here. Over here I need to write else. Else if there are elements present, then what do I need to do? Item equal to self dot head dot data, because we pop from the start, right? Self dot head, okay, then equal to self dot head dot next. 1 minute, I would explain this. Enter, and finally I just need to return with item. So basically what I am saying is, if I have removed the starting element from the queue, okay, for example there was 5 and I have removed 5, I have popped out 5, then 7, which is the next element, would become the new head. Okay, so that is what I am explaining over here. Okay, so I hope this is clear. 1 minute. Now I need to check if my solution is correct or not, so I would click on compile and run. So let's wait. There is a runtime error. Let's see what's the error. Okay, let's scroll down. Okay, 1 minute. Over here it should be is. Okay, over here space is space. Now let's click on compile and run again. Let's wait. Okay, the compilation is completed. My output is matching with the expected output, so now I would submit the given problem. Let's wait. Problem is solved successfully, and this is how you solve the practice problem implement queue using linked list. I hope this video was helpful for you and you guys enjoyed it. If you guys have enjoyed the video, make sure you click on the like button, and thank you for joining me today. Thank you.